Okay, 2.1. That's on page 84. We're looking at the absolute value of a real number. Looking at this graph here that we've got, this chart, sorry, that we have for temperatures. What observations can you make? Well, quickly we can see that September and May have an average temperature that are exactly the same. And February and June have the same except in opposite directions from zero temperature. And one positive, one negative. If we're looking at absolute value, reminding you what absolute value is, the distance from zero. They have the same distance from zero in February and in June. Okay, the construct your understanding, not going to have you do that, but just realizing that if we're talking about a distance between 2 points, distance is always going to be positive. We're not really caring in math about which direction the distance is going. Or if we're talking about area, area is always going to be a positive number. Okay, so every real number can be represented as a point on a number line. The sign of the number indicates the position relative to zero. Okay, so the magnitude of the number indicates the distance from zero. And you've been introduced to magnitude and direction in your science courses. We're just going to be looking at the magnitude right now. How far away from zero? Not worrying about direction. On the number line below, each of the numbers -2 and 2 is located 2 units from zero. So each number has an absolute value of 2. Again, distance from zero. Symbols for number sets. You went over a lot of these. So natural numbers, those are our counting numbers. 1, 2, 3, ... Whole numbers. Whole has an O in it, looks like a 0, so it includes 0 into the natural numbers. The integers, okay, can be either Z or I. Z is really just coming from the German word for number, Zahl, Z-A-H-L. But we can use I. So you can use I or you can use Z. Either one is fine. And these ones now bring in our negative whole numbers. And including all the whole numbers. Then our rational numbers, our cube. Those are anything that can be put into the form of a fraction. So, real definition, n over n, where m and n are integers. So you can either use I or Z. Really just meaning, hey, I can make a fraction of 2 integers. That's the rational numbers. Irrational numbers are the ones that cannot be put into a fraction. That bar top is the complement, meaning not rational. Irrationals. Those are things like pi, square root of 2, and that. Real numbers is all of the rational and irrational together. And then reminding you again that this symbol was an element of or belongs to the set of. And we've used this a lot with our domain and range. Using these conventions, the absolute value of a number A, where A is an element of the real numbers, is the distance of A from 0 on a number line. Okay, so finding the absolute value. Absolute value, distance from 0. So 4.2 absolute value, it's 4.2 units away from 0. Or in other words, we're going to make it positive. Absolute value of negative 6.1 is 6.1 units away. Negative 3 over 4 is positive 3 over 4, which, because the other two are in decimals, I'm just going to take it to a decimal as well, so I can, next part I got to put them in order, so I need to see what they are. And negative 1/2 is equal to 1/2 positive, or 0.5. So we're going to order them from greatest to least and show them on a number line. Put them in order. So therefore, we've got, of these, the smallest one is 0.5, then 0.75, then we've got 4.2, and then we've got 6.1 in that order. But I got to use the numbers that they gave me. So going back to there, the absolute value of negative 1/2 is first, then absolute value of negative 3/4 is second, then the absolute value of 4.2, and then the absolute value of negative 6.1. Those absolute value signs, they're really just, they're brackets with information, with a little bit of information, meaning make it positive, distance from 0. Putting them onto a number line, we've got 0, no point in going into the negatives, so I'm going to start 0, 1, 2, 3, 4, 5, 6, 7, and put them on there. So we've got right here, that first one, absolute value negative 1.2, and here is my second one, then the third one, 4.2, absolute value, and then absolute value negative 6.1. Suppose that the absolute value of A is known, and A is not 0. Can you determine the actual value of A? Well, no. We don't know if A was originally positive or negative. A could be positive or negative. We're not sure which one it was. All we know is that the absolute value gave us the number, gave us the positive value. So now an application of where we would use absolute value is the distance between 2 points. Determine the distance between 3 and negative 4 by counting the units. Okay, well, it's 1, 2, 3, 4, 7 units. Since the distance is always positive, it does not matter from which point that we start counting. Which direction do I go? Do I go from 3 minus negative 4? Or do I go negative 4 minus 3? Both of them are going to give me the same value when I look at the absolute value of it. They're both going to give me 7. So for distance, we want to calculate based on the absolute value. All I care about is that it's a positive distance. Distance between any 2 points, subtract them, take the absolute value. Use absolute value to determine the distance between each pair of numbers on a number line. So all we're going to do is, and sketch to illustrate. So let's draw a quick number line. We've got negative 8, so we need negative 9, negative 8, 7, negative 6, negative 5, 4, 3, 2, 1, 0. And I'm going from negative 8.5 to negative 3.7. And I want to know the distance between these two numbers. So using that little formula, absolute value of the two numbers subtracted. Doesn't matter which one we go first. As long as we subtract the two. So we've got negative 8.5 minus a negative 3.7 gives us a negative 4.8, but we're taking the absolute value, so the distance is 4.8. And just doing a quick little, it's pretty close to 5, so 1, 2, 3, 4, 5. Yeah, that looks right. There's A. Looking at B. Start the same way. Draw a quick little number line. Put on 2/3, just so that we can get it onto the number line easier. We're going to look at it as a decimal. That's 4.6 repeating, so 4.67, and negative 5 3/5 is going to give us negative 5.6. And let's put them on. So I'll put the 0 in the middle because they're both halfway on either side. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. There's 5. There's negative 5. And put your numbers on. So negative 5 and 3/5 on one side. And 4 and 2/3 on the other side. And I want to know the distance between those 2 points. Doing a just really quick estimate, we know that it should be about 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's go through the process. Absolute value of subtract the two of them. Negative 5 and 3/5 minus 4 and 2/3. Well, we've got to subtract them. We need common denominators. So easiest method is just to take them to improper. So 5 times 5 is 25, plus 3, 28, and it's negative. Negative 28/5 minus 4 times 3 is 12, plus the 2 is 14/3. Common denominator going to be 15 for this one. So I need it over 15. Over 15. I know that one is a negative. Multiply this one by 3, so 28 times 3 gives me 84. Need to multiply this one by 5. 14 times 5 gives me 70. So now, negative 84 minus 70. That's going to take me more in the negatives. Negative 154 divided by 15. Absolute value. Which then gives me positive, because I'm taking the absolute value, 154 over 15. Let's take that back to a mixed number. Well, 150 over 15 would have given me 10. So that's 10, but then I'm 4 more. So 10 and 4/15 units. And that's close to my estimate of 10. Okay, so we've been discussing this many times throughout this course, as well as last year, that 5 squared is 25, and negative 5 squared is 25. Please be careful with these. negative 5 squared is not the same thing as negative 5 squared. This first one says 5 squared, which is 25, with a negative in front. What we're looking at is actually squaring negative 5. Negative 5 times negative 5 is positive 25. So, if we look at this, we know that the square root of 25 has two answers. We've been doing that. We've always been putting plus and minus in front when we take the square root of a number. If they give you the square root, so looking at it just written as the square root of 25, we're taking with whatever sign is in front, positive. We don't put plus and minus if we didn't put the square root in front. That's called principal square root, and we've been working with this quite a bit this year already. The non-negative square root of a non-negative real number is called this principal square root. Just talk about that. So if we look at distance, again, if I'm saying x squared is the area, well, the side length has to be the principal square root, has to be the positive answer. Even though in this case, you actually would be taking the square root yourself. But a negative in this situation wouldn't make any sense for a side length. Or in other words, we're going to look at the principal square root being the positive answer, being the absolute value. Squaring and square rooting cancel each other off, leaving us just with x, but we want to say, hey, I've got the positive version of that. Absolute value does that for us. So just applying that into this situation here, if we notice, we say, oh, squaring and square rooting would cancel each other off, but I'm still going to have the absolute value. So 7 minus 10, because I know that this has to be positive, 7 minus 10 gives me negative 3. But because I would have been squaring this number, I need the absolute value. Taking it over this way, without using the absolute value, it would look like this. 7 minus 10 is negative 3 squared. Negative 3 squared is 9. Square root of 9 is 3 as well. Same answer. Just showing you another application of using the absolute value. The absolute value symbol is grouping signs. Or in other words, fancy brackets. Brackets are grouping signs. Absolute values signs are also grouping signs. So they act just like brackets do, except they've got a little bit more information to it. The brackets with a second level of information. And that's give the positive. When evaluating an expression that involves absolute value, treat the expression inside the absolute value symbol as a group. In other words, just pretend that they're brackets for that. Meaning, here. As soon as you've got the absolute value of negative 26 plus 13, treat what's inside the absolute values as brackets first for your order of operations. You can think of it this way, if that helps out. So do what's inside first. Okay, so negative 26 plus 13 gives us the absolute value of negative 13 minus 2 times the absolute value of negative 6. Absolute value of negative 13, that's positive 13. Minus 2. Absolute value of negative 6 is positive 6. But there's a multiplying sign in here. Now that we use the absolute value information up, we can just leave it with brackets. Then we get 13 minus 12, which gives us 1. Same thing here. We're being asked to substitute, though. So absolute value of negative 2 times 2 squared minus 3 times 2 minus 4. Absolute value. Keep those absolute value signs until you use them up. And that's right at the very end. You've got to do everything inside the absolute values first before you can use up the absolute value. Order of operations. Do what's in the brackets first. So negative 2 times 4 minus 6 minus 4, which is negative 8 minus 6 minus 4. We've got the absolute value of negative 18, which is 18. So that think further on the bottom of page 88 is a really good question to think about. It says, can a numerical expression involving absolute values have a negative value? Justify your answer. Well, taking the absolute value gives us a positive number, but can the answer be negative? And yeah, it could be, depending on what question they give you. For an example, if we took something like negative 5 times the absolute value of 2 minus 6. Well, this is going to be negative 5. 2 minus 6 gives us negative 4. Negative 5 times positive 4. So when we use the absolute value, yeah, we'll get a positive number, but now that I had a negative outside the absolute value, my answer could be negative at this point, negative 20. So just watch for that. That's what they're talking about.